this lesson, I'd like to talk about relays and contactors. The relay is an electronic device that consists of a coil and a set of contacts. The coil and the contacts are isolated and protected from each other. It's designed to be usable where one circuit must be controlling another. The coil is a spool of wire that's wrapped around an iron core. When the wire is energized or electricity is applied to it, there's a magnetic field that is generated. This field pulls in an armature that either opens or closes a set of contacts. When a relay is shown in the schematic, so it's always shown in the de-energized mode. The relay coil has a voltage rating. This rating is the voltage that you may apply to the coil. These ratings in HVAC are normally 24, 120, 208, or 230. You may not apply 120 volts to a 24-volt coil, and you may not apply 24 volts to a 120-volt coil. It has to match the coil. The coil is normally stamped on the side of the relay. If you take a look at the side of the relay, you'll find a stamp on each side of it. One side is usually for the contacts, the other is for the coil. The coil is a load. It does something. It does work. It uses power. The contacts are the switching devices of the relay. When the contacts are in the schematic, they're treated as an open or closed switch. Relay contacts normally come in two varieties. One is normally open, the other is normally closed. Relay contacts are attached to the armature that is moved by the magnetic force of the coil. The contacts have metal points that come in contact with each other. These points complete the circuit. Normally open contacts are the equivalent of an open switch. When the relay coil is de-energized, it is an open in the circuit. When the relay coil is energized, they close, just like turning on a light switch. When the coil is de-energized again, they open. The de-energized position is the normal position. Normally closed contact is opposite. When the normally closed contact is closed, it's a switch when it's de-energized. When the coil is energized, the switch opens and stops the current from reaching the load. When the coil is de-energized again, the contacts reclose. The contacts are rated with the number of amps they can control. The contacts are also rated with the type of load they can control. This would either be inductive, like a motor, or resistive, like a heater. Inductive just means magnetic. Resistive, it uses resistance to do the work. With inductive loads, the amperage spikes when it's started. We've already talked about motors a little. We're going to talk about them some more. But the amperage goes up as the motor starts to turn or as the load becomes energized. With resistive loads, the amperage remains constant. Make sure the contact ratings exceed the maximum amperage that load is rated for. Every component has a sequence of operation. A good technician can always describe the operation of a circuit to somebody over the phone, over the radio, or in person by giving a sequence of operation. That is, when this happened, what else happened, or what led to that. So the sequence of a Mars relay, when the relay is de-energized, there is no power across the coil. The contacts between points 1 and 3 are normally open. The contacts between points 1 and 2 are normally closed. The relay coil is energized with 24 volts. This closes the contacts between 1 and 3 and opens the contacts between 1 and 2. The schematic symbols of a relay, you have a relay coil. In this case, I'm showing it by a squiggly line. Sometimes it's shown just as a circle with a key. You have a normally open contact and a normally closed contact. Again, a relay is designed to control loads in the same circuit or in another circuit. An example of a relay in a circuit would be you have your coil C1 along with a normally open C1 and a normally closed C1. Notice, all parts of a relay are labeled with the same designator. That's how when you look at the circuit, you can see what the coil C1 controls. It controls two contacts. In example 1, the switch SW1 is open and the coil C1 is not energized. Thus, the normally open contact C1 is open and the green load is not energized. The normally closed contact C1 is closed and the red load is energized. Now, if I close the switch, energize the coil, you'll notice the normally closed C1 became open and the normally open C1 became closed. The switch has been closed, this energized the relay coil, C1. When the coil was energized, the normally closed contact C1 was open and it de-energized the red bulb. The normally open contact C1 was closed and this energized the green bulb. The Mars relay is one of the most frequent relays you'll see. It consists of a coil and two sets of isolated contacts. Each set has a common, normally open, and a normally closed terminal. When you look at the top of the relay, you'll see the commons are on the left-hand side. They're all numbered if you look closely at the plastic. Then you have your normally closed contacts. They're a little bit under the others. And then you have your normally open. The coil is your two unnumbered terminals at the bottom. And if you look closely at the side of them, you can see a wire going to the coil itself, which is at the bottom of the relay. And the electronic symbols, or the schematic symbols, you're normally open, and your coil. Normally closed, and your coil. And the layout of the relay is simple. Again, 1 and 4 are my commons, 3 and 6 are my normally opens, and 2 and 5 are my normally closed. You notice there's no electrical connection between the two sets. So you could have 120 volts on 1, 2, and 3. You might have 240 volts on 2, 5, and 6. And the coil is rated at whatever stamped on the side of the relay. It does not have to match the voltage of either sets of contacts. Contactors are really close in operation to relays. Contactors have 1 or 2 sets of contacts that are normally open. They're designed to be switching devices for loads with higher amperages. Most contactors use control voltage to control high voltage loads. In other words, the coil voltage might be low, might be 24 volts. High voltage loads might be 240 or 480. Contactor coils are again rated by voltage. Contactor contacts are rated by amperage. These ratings are normally written on the side of the contactor. Don't install a contactor that goes over either of these ratings. Picture of the contactor is here. The electrical symbols, you have your normally open, and you have your coil. And this would be a double pole contactor, 2 normally opens and a coil. Again, the voltages are not dependent on each other. You just have to make sure you match coil voltage and contact amperage. Troubleshooting contactors and relays is a matter of looking at voltages across loads and switches. In the following example, B2 is not working when switch 1 is turned on. Again, B2 is not working when switch 1 is turned on. So we take our circuit. We first check for source. Then we close the switch and check from well to the line side of SW1. We have 0 volts, so that line is good. We check from the L to the load side of SW1. That's the side facing the load. We have 0 volts. Switch is actually closed. We check from line to line side of C1. And again, 0 volts. We're fine. We check from L to the neutral side of C1. We have 120 volts. Now, that load might either be good or bad. Let's check a little further. Remember, voltage across a working load is 120, or source. Voltage across a bad load could also be source. We go to L to neutral side of C1, so we know that range is good. Now, we want to check from L to C1 of the contact. 0 volts, we have a good wire. Go to the other side, 0 volts, it's closed. Keep going, L to C2 coil, and L to neutral of C2 coil. Now we have 120, but that's okay, it's voltage across a load. Keep going, so we know the branch is good. Start from the top. Our problem, remember, is B2 is not coming up. L to line 1 of C2 contact. L to load of C2 contact. Okay, contact's closed. L to line of B2 load, we have 0 volts, so we have no open in that line. Go to the other side. L to load of C2 contact, 0 volts. Wait a sec. Voltage across a load, shouldn't we have 120 volts or whatever source is? Go to the other side of C2, we have source. Based on the last 2 measurements, the technician will determine that contactor B2 has a bad contact. The voltage across a load should not be 0. The voltage across a closed switch or contact should not be source. A relay and a contactor is an electronic mechanical device used by one circuit to control another. The voltage is the coil voltage. The amperage is how the contacts are rated. It can control 2 separate voltages in 1 or 2